Hello, I welcome you all to this another interesting screencast, and the problem reads that determine the force in each member of the truss and state if the members are in tension or compression. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So to start with, we're going to draw the free body diagram. We'll have EY at the roller, and then we'll have two reaction forces at the hinge, dy and dx. We are going to take moments about point D. So the summation of moments about point D equal to 0, anti-clockwise being our reference. We have a minus AY by 3. Then we have 4 by 6. Then we have 5 by 9, right, equal to 0, right? AY by 3 clockwise, and then 4 by 6, and then 5 by 9. AY therefore is just going to be equal to, so 4 by 6 plus 5 by 9 divided by 3. So this gives us a 23. So 23 kilonewtons. Then we have summation of forces in the y direction equal to 0. We have minus 5, minus 4, plus AY, plus dy equal to 0. We already found what AY is, so we can plug it there. And once we do, then we are going to have our dy, which is just equal to minus 5 minus 4, minus 5 minus 4 plus 23. Dy is equal to minus 14 kilonewtons. And then we have summation of forces in the y, summation of forces in the y, in the x equal to 0. Dx is just going to be equal to 0 kilonewtons. Right, so we have dx equal to 0. We have Ay equal to 23. And then we have dy equal to minus 14. Which just changes the direction there, right? Direction has to change. So let's just check this. We have 18 plus 5, 23, so it's equilibrating the y. Correct. So then let's start with joint D. Okay, so joint D, let me just draw just something like this. Alright, joint D, what do we have? So we have a 14 down there, and then we have, let's say this one is in compression, and then let's say this one is in tension. This is CD, and then this one is DE. Alright, then the slope for this, the slope is, we have the run of 3, okay, this is not too visible. Let me move this down a little bit. DA. So we have a 3 down, then we have a 5, then we have 3 squared plus 5, so we have root of 34. Okay, root of 34 like so. So we're going to have two components. We'll have one component like so. So this one becomes dA by 5 rise divided by root of 34. Then we'll have another one, this one, which is dA by run 3 divided by root of 34. Okay, so let's start with the y. Summation of forces in the y equal to 0. Going up in our reference, what do we have in the y? We have dA 5 divided by 14 minus 14. 5 divided by root of 34. Root of 34 minus 14 equal to 0. Therefore, dA is just going to be equal to, so we have a 14 divided by 5 divided by root of 34. So this gives us a 16.33 kilonewtons, and it is in compression as assumed. Then we have summation of forces in the x equal to 0. Okay, what do we have? We have dA 3 divided by root of 34. Okay, minus CD equal to 0. And then this is our dA, which we just feed in there. Therefore, we find that the value of CD is just equal to so we have 16.33 times 3 divided by root of 34. So this gives us 8.40 kilonewtons. And the direction that we assumed as tension is also okay. Right. So we are done with the first case. Right. Let's go to the next joint. So we'll say joint what? Joint E. Okay, I think maybe we'll move to somewhere here. Joint E. Okay, this one was D. So joint E, what we have, DE is in compression, so it will be coming in like this. And this value is DE's value is 16.33. This 16.33, and the slope, we already determined the slope. We have a 3, we have a 5, then we have a root of 34. Alright, and then we have a reaction force at the bottom. We have a reaction force at the bottom of 23, and this is E. And then we have, let's say this one is, let's say it is in tension. Okay, and this one is AE. Alright, and then let's say this one is in compression. Okay, this one, let's call it CE. So let's get components. Let's get components of these forces that are inclined, because each one of them will have components. Great. So let's start with defining the slope for AE. AE, we have the run of 6 and then the rise of 5 minus 3, which is 2. Therefore, this is going to be equal to 6 squared plus 2 squared. This is a 40. Alright. So we have this component for AE, we have this component like so. Like so. Okay, this one is AE times, this is AE times the run 6 divided by root of 40, and then we'll have another component. This one is AE times the rise, which is 2 divided by root of 40. Okay, and then we're going to have two more components. This one is 16.33 by the run, which is 3 divided by root of 34, and then we have 16 by 33 by 5 root of by root of 34, right? Great. I think that is fine. Which direction do we start with? It doesn't matter which one, because both of them have unknowns, right? We have AE in the X. Okay, I know the X is okay, right? The X direction is okay. We only have one unknown in the X, which is AE. Okay, great. So say summation of forces in the X equal to 0. Alright. What do we have? We have AE minus AE, 6 divided by root of 40, minus 16.33, 3 divided by root of 34 equal to 0. Therefore, my AE is just going to be equal to, so we have minus 16.33 by 3 divided by root of 34, and then divided by 6 divided by root of 40. So this gives me a minus 8.86 kilonewtons, and the assumed direction for AE is not correct, therefore this is in compression, right? Let me check it again. Minus 16.33 by 3 divided by root of 34, and then divided by or times root of 40 and divided by 6. Alright, so let's go to the other direction. Summation of forces in the y direction equal to 0, going up in our reference. So we have summation of forces in the y. So what do we have? We have a 16.33 5 divided by 34, root of 34, which is minus. Then we have plus AE 2 divided by root of 40, Then we have minus CE, then we have plus 23 equal to 0. So we found already what CE is, AE. Okay, so let's find what CE is. CE therefore is just going to be equal to, so minus 8.86 by 2 divided by root of 40 plus 23 minus 16.33 by 5 root of 34. So we have CE is going to be equal to 6.1, 6.2. Okay, CE is 6.20 kilonewtons, and this one we had assumed CE to be in compression, and of course it's in the right direction. So minus 16.33 times 5 root of times 5 divided by root of 34 plus minus 8.86 by 2 divided by root of 40 plus 23. So we have a 6.2. Alright, so we are done with E. We found AE. Let's join E. We found AE and CE. So let's close this one up. Let's close it up. Okay, we close it up like so. So let's go for join C. We go for join C. Go for join C. Okay. So what do we have for join C? We have CD. CD is in tension, and then we found CD to be 8.40, and then we have CE. CE is in compression. CE is in compression, and this is a 6.20. Okay, and then let's assume BC is in tension. All right, and then we have this other one here, which is CF. Of course, these angles here, this is a 3, we've seen this 3 by 3, so this one is 45, this is 45, and since this side also is 3, this is also 45, and also the top part there. All right, okay, this is also 45. Okay, so this one here is 45, and if that is the case, therefore we expect to have this one there. Let me just lift it a little bit, maybe I take it somewhere there. So this one is equal to CF cos 45, and then we'll have this one there. This one is equal to CF sine 45. Great. So we have summation of forces. Summation of forces in the y direction. Summation of forces in the y direction equal to 0. So we have CF sine 45, CF sine 45. We assume this one to be in compression, right? Alright, and then plus 6.20. Alright, equal to 0. 6.20, that is CE. Okay, therefore our CF is just going to be equal to 6.2 divided by sine 45. So this gives us a minus 6 point, I mean 8.77 kilonewtons, and therefore the direction simply means this is going to be in tension. Okay, then summation of forces in the x direction equal to 0, in this direction being our reference. We have CF cos 45, then we have minus BC, then plus 8.40 equal to 0. We already found what CF is. We found what CF is. Therefore, our BC is just going to be equal to, we have a minus 8.77 cos 45 plus 8.4. Therefore, we have BC equal to 2.20 kilonewtons, and this is in tension. Okay, so this is about it for this case. We found the components, right? So we are going to go to the next joint, which is joint B. Okay, this is joint B. So we have a force on top, which is a 4. BC is in tension, which is a 2.20. Okay, and then you have, let's say this one is in compression, BF, and then let's say this one is in tension. Okay, and we already know the angle to say this is 45. Alright, so we'll have components. We'll have one component in this direction. We said this one is AB. Okay, so this one here is going to be equal to AB cos 45. Then we'll have another one there, AB sine 45. Okay, sine 45. Alright, so there we go. So start with the summation of forces in the x direction. So say summation of forces in the x direction equal to 0. What do we have? we have minus AB cos 45 plus 2.20. 2.2 equal to 0. Therefore, our AB is just going to be equal to 2.2 divided by cos 45. So this gives us a 3.11 kilonewtons, and it is in tension. Alright, so therefore let's find the other components, summation of forces in the y direction. Okay, so we have minus 4 plus BF minus AB sine 45 equal to 0. We already found what AB is. Therefore, our BF is just going to be equal to, BF is equal to, so we have 3.11, so minus 3.11 sine 45 minus 4. So we have BF equal to 6.20 kilonewtons, and this BF is in compression as assumed. So minus 4 minus 3.11 sine 45. Alright, okay, so this is about it for this one. We can close this one here like so. Then we go to the last joint, joint F. Okay, joint F, we have BF, which is in compression, so we expect it to be coming up like so, which is a 6.2. And then we have CF is in tension, so we expect this to be going up like this. So let me write this. Okay, this is CF. What is CF? CF is 8.77. Okay, 45. Right, that is 45. This is 45. All right. And then we have this one here. Let's say this one is in tension also. Let's say this one is in tension, and this is AF. So we'll have two components from 8.77. We'll have this component, which is just 8.77 sine 45, and then we'll have another one there, which is 8.77 cos 45. Great. So we'll say summation of forces in the x direction equal to 0, in this direction being our reference. We have minus AF, then we have plus 8.77. We have 8.77 sine 45 equal to 0. Therefore, AF is just going to be equal to 8.77 sine 45, it gives us a 6.20 kilonewtons. And as assumed, this is in tension. We can prove the other one, which is summation of forces in the Y. It must equilibrate with the other component. We are just proving this. This is supposed to equilibrate. So we have minus 6.2 plus 8.77 cos 45 and for sure this gives us a 0 because sine 45 and cos 45 will give us the same result, which is a 6.2. So this is a 0 grade. So it means our work is okay. So let's outline the final solutions. We have DE, which is in compression. We have CD, which is in tension. We have AE, which is in compression. We have CE, which is in compression. We have CF, which is in tension. And we have BC, which is also in tension. We have AB, which is in tension. And we have BF, which is in compression. And then we have AF, which is in tension. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Great. Alright, I guess we are done. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.